Hello boys and girls, this is Mr. Kizik, and in this video we're going to look at some parallelogram proofs. Now I will say, with these proofs here, there's many different ways about, or many different kinds to go about solving these. So we're not going to look at every single one that you have in your packet, but we are going to look at a few. So if we recall here, what is the definition of a parallelogram? Remember, it's a quadrilateral where the opposite sides are parallel. So if I look here, number one, it says given angle BAC, so let me mark that down here, is congruent to angle DCA, and angle BCA is congruent to angle DAC. Prove that this figure is a parallelogram. So remember, with these proofs too, you won't necessarily need to have to use every single line here. So remember, the first thing what we have for a proof, that's right, it's the given statements. So I'm just going to be a little bit lazy here and write the two given statements. Okay. Now, one of the ways to prove something's a parallelogram is we can prove, or the main reason is prove that the opposite sides are parallel. Well, if I think back here, in order for these two angles to be equal, they have to be parallel. But what was that little theorem that we talked about, in chapter 3, that says if these two angles are congruent, then the ones have to be parallel? Well, if you recall, we can say that BC, line BC, is parallel to line AD, and then on the same line, we can also say BA is parallel to CD. As you recall, it was called the alternate interior angles converse. Remember when we did that lesson where we said these two angles are congruent because why? And we had to say, oh, they're alternate interior angles, and that was a converse statement. Well, that's what you're doing here. Well, I've now shown, because these two are alternate interior angles, I've said that those two sides are parallel. So now we can say that figure ABCD is a parallelogram because that's the definition of parallelogram. Okay. So let's look at another one here. This one says WX is congruent to YZ. Yeah, right here. I don't know why blanking out there. Congruent to YZ. And WZ congruent to YX. Prove that's parallelogram. So let's do the same concept here. Now, however, in this case here, we can't say anything about the alternate interior angles yet, right? I can't just go and say, well, angle WXZ is congruent to angle YZX because alternate interior angles. We don't know that. So, start off here, we've got the two givens. Now, what we could say is we could utilize, because remember, everything can be broken down to triangles. I can utilize properties of triangles or congruent triangles to talk about those angles. So I can say like XZ is congruent to XZ because of reflexive property. And then I can say that the two, so I'll mark this down. So now I can say that the two triangles, triangle WXZ is congruent to triangle YZX because of SSS. So now, since we've proven that the two triangles are congruent, we can now say that angles WXZ is congruent to angle YZX, and we can say that angle YXZ is congruent to angle WZX because of CPCTC. So now we've talked about, and now we can say that these alternate interior angles are congruent. So now we can say WXYZ is a parallelogram because, actually, yeah, because definition of parallelogram. I did actually miss a line here. So between there, my bad here. So between here and here, we would have to say that XY is parallel to WZ, and we would have to see XW is parallel to YZ because of the alternate interior angle converse. And then we can say that the figure's a parallelogram because it's a definition there, because we've proven that the lines are parallel. That's my bad. So let's look at this one here. This is why I don't like when they give you just the lines too, because when you miss something, you can't just easily go back here. So what we're going to do to help this, so for number 3, they gave us 2 givens. So let's just pretend we wrote both given statements right there. And let's also mark it down. So it says PQ is congruent to RS. We can mark that down. Now it says PQ, whoops, excuse me, is parallel to RS. So what does that mean? Remember, when I got parallel lines, it means angles are going to be congruent, right? So we can say angle. So we can say angle QPR is congruent to angle SRP because those are alternate interior angles. Then we can say that PR is congruent to PR because of the reflexive property. And now we've proven that, now we can say that the 2 triangles are congruent. We got enough information. We can say triangle QPR is congruent to triangle SRP because of SAS, which then we can say that angles, so now we can talk about the alternate interior angles so we can get to the parallel lines. So now I can say angle QRP is congruent to angle SPR because of CPCTC, which then we can make a statement that QR is parallel to PS because of the alternate interior angles converse, which now we can say, because we've shown that opposite sides are parallel, we can say figure PQRS is a parallelogram because, well, that's the definition of parallelogram. And that, ladies and gentlemen, is the main way of showing something is a parallelogram. Well, now, what happens if I told you you're given a parallelogram and, and then you have proved that, some sides or angles are congruent here. So if I look at number 4 here, it says given JKLM is a parallelogram, prove that JK and LM are congruent, and JM and LK are congruent. And you might correctly be, you might be thinking, well, isn't that the definition of parallelogram? Opposite sides congruent? And you're right, that is a property But why is it a property? The only real definition of a parallelogram is that um, opposite sides are parallel. So after I write the given here, what does the given tell me? Well, it's just all that it really tells me is that JK is parallel to LM and JM is parallel to KL. So what does that actually tell me or give me? That gives me alternate interior angles being congruent. So I can say, let's put in one line here, angle KJL is congruent to angle MLJ, and also angle MJL is congruent to angle JLK. Oops. Because they're alternate interior angles. Next, we can talk about what the shared line here. So we can say JL is congruent to JL because of reflexive property. And now we can say that the two triangles, we can say triangle JKL is congruent to triangle LMJ because of ASA. And now we could just go right to saying, well, that means JK has to be congruent to LM, and JM has to be parallel to congruent to LK because of good old CPC-TC. And we talked about this, last chapter too, right? When we had this and we were proving the two triangles are congruent. Same concept here, except now I'm saying the whole figure is a parallelogram, and it helped me get alternate interior angles. So because of the program I'm using here, time is running out, and I don't want to be cut off during the middle of a problem. So what I'm going to do here is I'm going to finish this video, and then what I would like you to do is watch part 2 of proofs with parallelograms.